Good to have you back. Here is a set of new questions for the final exam review. And for the purpose of this lesson, it is specifically for the foundation and pre-calculus 10 or algebra 1/algebra 2. And if you're in BC, that's the foundation and pre-calculus 10. All right, so first question, cost of hiring electrician versus time. The graph is given to you, and the idea is we want to know what is the cost of hiring an electrician for 8 hours. Now, this graph has everything that you need. You need to extrapolate the information from this. So let's go ahead and do this. Now, it looks like a linear function. Okay, and if it is a linear function, remember linear function was given as y equal to mx plus b. Okay, and if that's the case, all we have to do, we want to find the slope. Well, the slope is very easy. You just look at the graph, you go up 50, or yes, it is 25 actually, and then over half. So the slope m is you're going up 25, rise over run, and over half. That means the slope is 50. Okay, rise over run, cost over time. So that's his C over T. That's the unit. Okay, so now that we have that, so we have the M. What is B? The B value is the y-intercept. Look at this graph. Where does this graph intersect with the y-axis or the cost? Well, it's at 75. So B is $75. Okay, so here we go. Now we're going to rewrite y equals to 50x plus 75. Okay, and now you can either plug in the 8 hours in here for x, because x is the number of hours. This is your t, basically. I could have written it as t, and that's okay too. You could do that, right? And then you plug it in, 8 of x, and y equal to 50 times 8, that's 400, plus 75, that's 475 in total, which is the answer for this question. Answer is B. All right, fantastic. That's the first question. All right, by the way, is this the only way to do this question? No, it's not. You could actually continue this plot and extend this time out more and hit the 8 hours and go up and match the graph as it continuously going up, because the slope is the same, right? Slope is continuously the same at 50, and then match it and then read it off of there too. That's okay too. That is great, but I just wanted to do this way just to give you a review of the standard form or a slope-intercept form of a linear function or a line, so that you have something to go with and review, as well as calculating the slope and y-intercept. Okay, very good. Now let's look at another question. This is a good question. Simplify this expression, and we are using exponent laws. Okay, so here it is. So again, a couple of ways of doing this. I wouldn't mind simplifying the inside of the bracket first. So 25 and 125. So we know 25. How many times 25 goes into 125? Well, is it a 4 times or 5 times? Oh, it is 5. Actually, I made a mistake. Right. This is 5. Okay, so now that we have that, we can go and simplify. Well, this is actually x to the, that's x to the 3a, exponent laws. This is the power of power. You multiply the exponents, and the denominator is 5 to the third x to the ninth. Okay, and when you do this, you get the denominator is 125, but the x value will end up being x to the exponent of 3a minus 9. Okay, so remember, division of the expression with the same base you subtract the exponents. So 3a minus 9, that would be the answer to that. Now, so which one will be the answer? Will be A. This one is, we are doing factoring. Which of the following expressions have factor of x plus 2? So we got three different expressions. We want to know which one of these have a factor of x plus 2. Well, the best thing to do is just go through factoring. All right, so first one right here, this is difference of squares. That's x minus 2, x plus 2. Okay, that's the difference of squares. You got to factor it, then that's what you will get. This one, you have to do a freestyle factoring. All right, so this one, you'll get 2x minus 5 and x plus 2. And the reason is that when you multiply these, you'll end up getting, and when you multiply them and then add them, these are the x terms, you get minus x. And then when you multiply minus 5 and 2, you get minus 10, so you get that back. So that makes sense. And then, of course, this one right here, you just, GCF is 5, take that out, and you get x plus 2. So notice that x plus 2 is showing up in every single case. So let's change the color. Let's go to red. So we have x plus 2 here. You have x plus 2 here. We have x plus 2 there. So all three of them. So D is the answer there. Okay, very good. Now let's look at another one. Last one. All right, so given the area of a rectangle below is 2x squared plus 9x minus 5, determine the length of the rectangle. So basically now you know that to find the area of a rectangle is length times width. So if this is the width, all right, so W times L, that's the area of the rectangle. All right, so what it is that x plus 5, when you multiply it by another binomial, you'll get 2x squared plus 9x minus 5. All right, so what are we going to do? Well, here is the one of the factors, x plus 5. The second bracket, the first term of second bracket must be 2x, because 2x times x will give you 2x squared. Very good. And then the last term, you're going to have minus 5. So 5 times this last term in the second bracket must be, when you multiply them, you get minus 5. And that's just minus 1. There's no other option to do that. So when you do the math and then you expand it, you'll end up getting 2x squared plus 9x minus 5. All right, so 2x minus 1 is the length. All right, A is the answer for that. All right, I hope you found this useful. 3 questions. Here's the linear function question right from the beginning. It was the word problems, and then coming up with the answer. The next one was the exponent laws and simplifying an expression using exponent laws. Last 2 were basically factoring in different form. One is the finding out different factors of different polynomials, and then the last one was the word problems involving factoring. All right, hope that you found this useful. If you have any comments or anything else that you want me to go over, please leave a comment below. I'll see you in the next video.